Hello, in this lecture we'll find out the radius of a circle. In the drawing we have the right triangle ABC. Inside this right triangle we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is a right angle. This is line segment AS that is equal to 1 unit in its length. This is line segment ST that equals to 3 units in its length. And finally, this is line segment TC that equals to 2 times 4 to 3 units in its length. Repeat again that our mission is to find out the radius of this circle. So in the first step, we define the center of this circle. This point is O. And we define the radius of this circle as x. So our mission is to find out the value of x, that is the radius of this circle. Okay. In the next step, we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is a point on the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x according to our definition. You can implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also tangent AB. This is tangent AB, that is tangent to this circle at this point, point M. Point M is the point of tendency of tangent AB with this circle. And we have also the radius OM, that's equal to R. So the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP is the radius of this circle, that is equal to x according to our definition. So we have here the radius OP that is equal to x, so the radius OP is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside this quadrilateral OPBQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So the fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral OPBQ to 360 degrees, the fourth missing angle must be equal to 90 degrees in its size. So actually, we actually found out that inside this quadrilateral POQB, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to this quadrilateral POQB that has 4 right angles as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X, because they are equal to each other. Likewise, according to the same rule, in rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X, because they are equal to each other. So actually found out that this quadrilateral POQB is not a rectangle but a square. Why? Because all the 4 sides of this quadrilateral POQB are equal to each other. Its size is equal to X units in its length. Therefore, this quadrilateral POQB is a square. In the next step, we define the length of this line segment AP as A. And we define the length of this line segment QC as B. In the next step, we'll implement on this drawing, on our drawing, Rule 10. I repeat quickly on Rule 10. According to Rule 10 is true in any Rule 10 is true in any circle. So in any circle, if AB is a chord, here we have chord AB. If AB is a chord in the circle and PT is a tangent to the circle, tangent PT is tangent to this circle here at point T, then in this drawing the following equation will be true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. We can actually implement Rule 10 in our drawing. Why? Because in our drawing, if we focus on this common external point A, from this common external point A, we have tangent AP that is tangent to this circle here at this point P. And we also have chord TS, or the extended chord TS, touches this common external point A. So all the requirements of Rule 10 are satisfied, and therefore we can implement here Rule 10. According to Rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it down. I repeat again. If you focus on the common external point A, then the following equation will be true, that AP square equals to AS times AT, according to Rule 10. So AP equals to A, therefore AP square is A square, and it is equals to AS is 1 times AT. From the drawing, it is very easy to see that AT in total equals to 1 plus 3. AT equals to 1 plus 3. So in conclusion, I actually found out that a squared equals to 1 times 1 plus 3. So a squared equals to 1 times 1 plus 3, that is 4. So it is 1 times 4, that is 4. A squared equals to 4. We'll take a root out of this equation. And finally, we get that a equals to the square root of 4, that is 2. So we actually found out that a equals to 2 units in its length. So I write it down in the original drawing here, that a equals to 2 units in its length. Likewise, we'll implement rule 10 on this correct standpoint, point C. Actually, from this common standpoint, point C, we have tangent CQ, that is tangent to this circle here at this point Q, and we also have the extended chord ST touches the common standpoint, point C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, CQ squared equals to CT times CS. Repeat again. According to rule 10, if we focus on the common standpoint, point C, CQ squared equals to CT times CS. CQ is B, and therefore CQ squared is B squared, and it is equals to CT. CT is 2 times square root of 3 times CS. CS or SC, CS equals to 3 plus 2 times square root of 3. It is very easy to see from the drawing that CS equals to 3 plus 2 times square root of 3. So in conclusion, I actually found out that according to rule 10, B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We will open the brackets on this side of the equation, and we get that B squared equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 is 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 3 times 4 is 12. So in conclusion, I actually found out that B squared equals to 2 times 3 times square root of 3 plus 12. So B squared equals to, we have here 12, we substitute 12 by 9 plus 3. And we get that B squared equals to 9 plus 3 plus 2 times 3 times square root of 3. So actually this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the expression of A squared plus B squared plus 2 times A times B. Those two expressions are equivalent to each other if we just substitute A by 3 and B by square root of 3. Then we get that A squared will be equal to 9 plus B squared is square root of 3 squared, that is 3, plus 2 times A, that is 3, times B, that is square root of 3. Okay, so a squared plus b squared plus 2 times ab equals exactly to 9 plus 3 plus 2 times 3 times square root of 3 if we just substitute a by 3 and b by square root of 3. But this expression a squared plus b squared plus 2 times ab equals to a plus b squared. This is an algebraic identity. And therefore, this expression 9 plus 3 plus 2 times 3 times square root of 3 must be also equal to a plus b squared if we just substitute a by 3 and b by square root of 3. That is to say, this expression must be equal to a, that is 3, plus b, that is square root of 3 squared. In conclusion, I shall find out that 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared. And because of the fact that those two expressions are equal to each other and those two expressions are also equal to each other, it means that those two expressions must be also equal to each other. Again, because of the fact that those two expressions are equal to each other and those two expressions are equal to each other, therefore those two expressions must be also equal to each other. That is to say, b squared must be equal to 3 plus square root of 3 squared. So we take a root out of this equation, and finally we get that b equals to 3 plus square root of 3. So we can find out that b equals to 3 plus square root of 3, but square root of 3 equals to 1.732, therefore b that equals to 3 plus square root of 3 will be equal to 4.732. So actually found out that b equals to 4.732 units in its length, and we already found out that a equals to 2. So I write it down here. We found out that line segment Q3 that equals to b is equals to 4.732 units. And we have already found out that this is line segment AP that is equal to A according to our definition, A equals to 2. So in the next step, we'll implement the Pythagoras theorem in the big right triangle, triangle ABC. Here by PT is the information for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. I'll repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So what is the length of the hypotenuse AC? From the drawing it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total, AC equals to 4 plus 2 times square root of 3. And therefore, AC squared will be equal to 4 plus 2 times square root of 3 squared. Plus, and it is equals to AB squared. AC squared equals to AB squared. AB, from the drawing, it is very easy to see that AB equals to x plus 2. Therefore, AB squared equals to x plus 2 squared. Plus BC squared. BC equals to x plus 4.732. Therefore, BC squared will be equal to x plus 4.732 square. In conclusion, we found out actually that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. So 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, x plus 4.732 square equals to x square plus 4.732 square. 4.732 square equals to 22.3918 plus 2 times x times 4.732, that is equals to 9.464x. So in this side of the equation we have 55.7128. On the other side of the equation we have here x squared plus x squared is 2x squared. And we have also here 4x plus 9.464x equals to 13.464x, plus we have here 4 plus 22.3918, that equals to 26.3918. In conclusion, we actually found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtract 55.7128 from this equation, and we get that in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128, that is actually equals to minus 29.321. So in conclusion, I actually found out that 0 equals to 2x squared plus 13.464x minus 29.321. Here we divide this quadratic equation by 2, and we get that 2x squared over 2 is x squared, and 13.464 over 2 is 6732x, and minus 29.321 over 2 is minus 14.66, that equals to 0. So finally we actually found out that x squared plus 6.732x minus 14.66 equals to 0. This is of course a quadratic equation, and then our formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. and we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0. So in our quadratic equation, x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1. The coefficient b equals to 6.732. And finally, the coefficient c equals to minus 14.66. So we just have to put the values of a, b, and c, those values, inside the general formula for x. Repeat again, the general formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we just have to put the values of a, b, and c for our specific quadratic equation inside this general formula for x in order to find out the value or the values of x for our specific quadratic equation. I will remind you that x in our specific quadratic equation is the radius of this circle. So we'll do it now, and we'll get that x for our specific quadratic equation, x will be equal to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of 6.7 square root of b squared. B is 6.732, therefore b squared is 6.732 squared. That is equal to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is minus 14.66, so minus 4 times minus 14.66 equals to plus 58.64. So inside the root we have 45.3198 plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So actually found out that x equals to minus 6.732 plus minus, and 45.3198 plus 58.64 equals to 103.9598 divided by 2. So actually found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we will have two solutions that are possible for x. The solution that x equals to minus 6.732 minus 10.196 is definitely a negative number, but x cannot be a negative number. Why? Because of the fact that x is the radius of this circle. A radius is a length, and the left must be a positive number. So the negative solution is irrelevant, is incorrect solution. So we'll focus on only on the positive solution. We'll take into account only the positive solution for x. And the positive solution for x is x equals to minus 6.732 plus 10.196 over 2. And minus 6.732 plus 10.196 equals to 3.464 divided by 2. So x equals to 3.464 over 2, that is equals to 1.732. In conclusion, we actually found out that the radius of the circle that's equal to x is equals to 1.732 units. Repeat again. The radius of this circle that is equal to x is equals to 1.732 units. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have, this is the right triangle ABC. Inside this right triangle, we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is a right angle. This is line segment AS, that is equals to 1 unit in its length. This is line segment ST, that is equals to 3 units in its length. And finally, this is line segment TC, that is equals to 2 times square root of 3 units in its length. Repeat again that our mission is to find out the radius of this circle. So in the first step, we actually define the center of this circle, this point as O, and we define the radius of this circle, that is the radius that we are looking for in this question, as x. So our mission is to find out actually the value of x, that is the radius of this circle. In the next step, we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and then at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x according to our definition. We implemented here rule 1. Why? Because we have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO according to rule 1. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x. Again, we have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to the same rule, rule 1. So, inside this quadrilateral POQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of this quadrilateral POQB to 360 degrees, the fourth missing angle must be equal to 90 degrees in its size. So inside this quadrilateral POQB, we have 4 right angles. and any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrangle POQB that has 4 right angles as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the sum rule, in the sum rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to each other. OQ equals to x, therefore PB must be also equal to x because those two sides are equal to each other. So actually inside this quadrangle POQB, all the sides are equal to each other, therefore this quadrangle is not a rectangle but a square. In the next step, we define this line segment AP as A, and we define this line segment QC as B. Here we implemented rule 10. Repeat quickly on rule 10. According to rule 10 is true in any circle. So in any circle, if AB is a chord in the circle and PT is a tangent to this circle at point T, then in this drawing the following equation will be true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. We can implement rule 10 in our drawing. Why? Because in our drawing, if we focus on this common external point A, from this common external point A, we have tangent AP, that is tangent here at this point P to this circle, and we have also the extended chord TS touches the common external point A, so all the requirements of rule 10 are satisfied, and for that reason we can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Because again, if we focus on the common standpoint, point A, according to rule 10, we get that AP square equals to AS times AT. So AP square, AP is A, therefore AP square is A squared, and it is equals to AS, that is 1, times AT, that is 1 plus 3. So in conclusion, actually found out that A square equals to 1 times 1 plus 3, that is to say A square equals to 1 times 1 plus 3, that is 4. So A square equals to 1 times 4, that is 4. A square equals to 4. We took out of this equation and finally found out that A equals to the square root of 4, that is 2. So line segment AP, that is equal to A according to our definition, is equals to 2 units. Likewise, we implemented rule 10 on this common external point C. From this common external point C, we have tangent CQ, that is tangent to this circle here at point Q, and we also have the extended chord ST touches the common external point C, so all the requirements of rule 10 are satisfied, and for that reason, we can implement rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Okay, again, if we focus on the common standpoint point C, according to rule 10, CQ square equals to CT times CS. CQ equals to B, therefore CQ square is B squared, and it is equals to CT. CT is 2 times root of 3, and CS is 3 plus 2 times root of 3. So in conclusion, we actually found out that B squared equals to 2 times root of 3 times 3 plus 2 times root of 3. We opened the brackets on this side of the equation and finally found out that B squared equals to 2 times 3 times root of 3, and 2 times square root of 3 times 2 times square root of 3 equals to 12, because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in conclusion, we actually found out that B squared equals to 2 times 3 times square root of 3 plus 12. Here we substituted 12 by 9 plus 3, and finally found out that B squared equals to 9 plus 3 plus 2 times 3 times square root of 3. This expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the expression A squared plus B squared plus 2 times AB. If we just substitute A by 3 and B by square root of 3, we get that a squared plus b squared plus 2 times ab equals to 9 plus 3 plus 2 times 3 times root of 3. But this expression a squared plus b squared equals a squared plus b squared plus 2 times ab is equals to a plus b squared. This is actually an algebraic identity, and for that reason this expression 9 plus 3 plus 2 times 3 times root of 3 must be also equal to a plus b squared if we just substitute a by 3 and b by root of 3. Okay, so here this expression equals to a that is 3 plus b that is equal to 3 squared according to this algebraic identity. So those two expressions are equal to each other, and those two expressions are also equal to each other, and therefore those two expressions must be also equal to each other. That is to say, b squared equals to 3 plus square root of 3 squared. We took a root out of this equation and finally found out that b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. So I actually found out that line segment QC that's equal to B is equal to 4.732, and we have only found out that line segment AP that's equal to A is equal to 2 units. In the next step, we actually implemented the Pythagoras theorem on the big right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB plus AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. What is the length of AC? From the drawings it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times root of 3. So AC in total equals to 4 plus 2 times root of 3. Therefore AC squared will be equal to 4 plus 2 times root of 3 squared. Here AC squared equals to 4 plus 2 times root of 3 squared. And it is equal to AB squared. AB is x plus 2. Again, AB is x plus 2, therefore AB squared is x plus 2 squared. So AB squared is x plus 2 squared plus BC squared. BC is x plus 4.732, therefore BC squared equals to x plus 4.732 squared. Again, BC squared equals to x plus 4.732 squared. In conclusion, we actually found out that 4 plus 2 times root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. And 4 plus 2 times square root of 3 squared equals to 55.7128, and it is equal to x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 squared, so x plus 4.732 squared equals to x squared plus 4.732 squared, that is 22.3918, plus 2 times x 0.4 plus 2 times x times 4.732, that equals to 9.464x. So in this side of the equation we have 55.7128. In the other side of the equation we have x squared plus x squared is 2x squared, 4x plus 9.464x is 13.464x, and 4 plus 22.398 equals to 26.398. In conclusion, we actually found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. We subtracted 59.7128 from this equation. So in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 2x squared plus 13.464x and 26.3918 minus 55.7128 equals to minus 29.321. So in conclusion we got the quadratic equation that 0 equals to 2x squared plus 13.464x minus 29.321. Here we divided this equation, this quadratic equation by 2, and finally found out that 2x squared over 2 is x squared, 14.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66, and it is equals to 0. So in conclusion, actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is of course a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 6.732x minus 14.66 equals to 0. So in this quadratic equation, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just have to put the values of a, b, those values of a, b, and c in our specific quadratic equation inside this general formula for x, in order to find out the value or the values of x in our specific specific quadratic equation. I remind you that x in our quadratic equation is the radius of this circle. And the general formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the values of a, b, and c from our specific quadratic equation in this general formula for x, and found out the value of x. We did it here, and we found out actually that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4, times c. C is minus 14.66, so minus 4 times 1, minus 14.66 equals to plus 58.64. So inside the root we have 45.3198 plus 58.64 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in conclusion, actually found out that x equals to minus 6.732 plus minus, and inside the root we have 45.128 plus 58.64 equals to 103.9598 divided by 2. So actually found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. The first solution is a negative solution, that is to say it is minus 6.732 minus 10.196. That is definitely a negative number, but x cannot be a negative because of the fact that according to our definition, x is the radius of this circle, and the radius is a length, and the length must be a positive number. So the negative solution is a relevant solution, is not correct solution. So we'll focus on we take into account only the positive solution for x. And the positive solution for x is x equals to minus 6.732 plus 10.196, that is actually 3.464 divided by 2. So and 3.464 over 2 is 1.732. In conclusion, actually found out that x, that is the radius of this circle, equals to 1.732 units in its length. Okay, thank you very much.